Hey guys, this is MathHeads 101, and today I'm going to be showing you how to get the integral under the area under a bell curve. So we're going to take the integral from minus infinity to infinity of e to the minus x squared dx. And I just put that circle for reference because I know that if I draw inside here, you're not really going to be able to see it. Like I just drew a smiley face and you can't see it at all. So hopefully you'll be able to see everything I do. Okay, so basically I'm going to call this I. Okay, just some constant. And really, this is an integral that by itself we can't take. But if we square it, it will be easier to take. So I'm going to take the integral again. And so it's going, I squared is equal to, I squared is equal to the integral from minus infinity to infinity of e to the minus x squared dx times the integral from minus infinity to infinity of e to the minus y squared dy. So I put a different variable, but those will calculate the same thing. Okay? Now, since I put a different variable, I can just make this a double integral. And if I make this a double integral, since the things are since what I'm calculating is not based off of the other one, it won't affect it. Okay, so this is equal to the double integral from minus infinity. Both of them are from minus infinity to infinity. So the order again doesn't matter because they're the same bounds. Dx dy of e to the minus x squared times e to the minus y squared. Okay, so now what is that equal to? I'm going to erase this. So that, in the blue, that's equal to, well, if you have e to the minus x squared times e to the minus y squared, so that's going to be the double integral from minus infinity to infinity of then another integral from minus infinity to infinity. And then we have e, and then it's going to be to the minus x squared minus y squared. Because if you know the laws of exponents, when you multiply two things with the same base to some power, you just add the power. Okay? Or, well, in this case, subtract dx dy. Okay. Now I can be like, okay, well, this looks like x squared plus y squared is a circle, so that's pretty useful if we want to switch to polar coordinates. So I'm going to rewrite that as this is equal to the double integral from minus infinity, both of them, to infinity for both of them, of e to the negative, and then we have x squared plus y squared, and then we have dx dy. Okay, now we're going to convert the integral to polar coordinates. I'll do that in red. Okay, so first off, an integral in polar coordinates, we know that dx dy is equal to r dr d theta. So it's going to be equal to the double integral in polar coordinates, and then in the end we're going to have r dr. Or actually, I'm going to do it in the other order. Usually, you use r dr d theta, but I think that for this one, it'll be easier to do r d theta dr. Now, if we're putting thetas on the inside, so we're going to put a theta here and an r here. So now, if we want to cover the whole plane, because here we're covering the whole xy plane. So to do that, well, theta goes from 0 to infinity, and r goes. Well, no, theta doesn't go from, that doesn't make sense. Theta goes from 0 to 2 pi. I'm sorry about that. And r goes from 0 to infinity. Yeah. Okay. So you're going around the whole circle, every length. Okay? And now what do we have? Well, we know that x squared plus y squared is equal to, well, the square root of x squared plus y squared is equal to r, right? If you graph if you graph the square root of x squared plus y squared equals 1, that looks like a circle. right? Well, if you guys pull from plus or minus that. So if you just take this, that's equal to r squared, okay? So we have e to the minus r squared. So now we have the integral in polar coordinates. Hopefully that'll be easier to take than the integral in Cartesian coordinates. And then, remember, we still have I squared. So we want I, so we'll just take the square root of our answer, whatever we get. Okay, I don't need that anymore. Well, let's first compute the inside integral. That shouldn't be too bad, because we're doing d theta, but there's no thetas in here. So really, it's just, everything's a constant, so everything pops out. So it's going to be the integral from r equals 0 to infinity, and then of e to the minus r squared times r, and then we have times this integral from theta equals 0 to 2 pi, and then we have d theta, and then we're going to have a dr. So basically we get this part, and then once we have this part we can calculate the whole thing. So that part, okay, so I'm going to rewrite the outside part, and then in blue I'll figure out what the inside part is. So the outside part is the integral from r equals 0 to infinity of e to the minus r squared, r, and then d theta. And what is that going to be? That inside integral. I'm going to do that in blue over here. Okay? So that integral over there, that is equal to, well, it's just going to be theta from 0 to 2 pi, which is equal to 2 pi minus 0, which is equal to 2 pi, right? So I can just write 2 pi instead of that integral here. So now we're down back to one integral. That's pretty good. Now, what else do we have? Well, if we take a look, this integral shouldn't be too bad, because really, e to any power is, that's not hard to take an integral of, but we're going to have this r, and so let's just do a quick, easy u substitution, and I'm going to write the integral so it looks simpler to take, okay? So we have 2 pi times the integral from r equals 0 to infinity of e to the minus r squared r dr. That's our integral. Okay? So let's do a quick u sub. Okay? So I'm going to say u is equal to, well, if we have e to the u, the integral of e to the u is e to the u. So that'll be useful. So we're going to say e equals minus r squared. That way we're just going to have e to the u. So du is equal to minus 2r dr. And we do have a 2 and an r. So if we write this integral, well, first off we have to say it's from r equals 0 to r equals infinity. So when r equals 0, implies that u equals, well, u is minus r squared. So when r is 0, u is 0. When r is equal to infinity, that implies that u is equal to negative infinity. So now we have our integral, and instead of being from 0 to infinity, it's going to be from 0 to negative infinity. So that's kind of weird, but you'll see that'll work out later, because look, du is minus 2r dr, but we don't have a minus 2r dr, we just have a 2r dr. So we're going to put the minus sign on this side. Okay, so now we're going to have to put a minus du. So we have a du, I'll put the minus sign in front because we're allowed to do that. And then everything else we have, well, we don't have a pi, so I'll put minus, and it's pi times e to the u, and then 2 RDR. Well, here's the 2 and here's the RDR, so that really just became the du, right? So it's, I'll put the du here, okay? So we don't need that anymore. So we have the integral from minus pi times the integral from 0 to minus infinity of e to the u du, which is equal to, well, if we want it to be a normal integral, we want the lower bound to be lower. So if we swap that, we're going to have to make it negative. So it's really just pi times the integral from minus infinity to 0 of e to the u du. So now we're just down to a very simple integral. I'll write it big because we're happy. We're pretty much at our answer now. Okay, so let's see. We have, that fell, but I don't even care. Okay, so we have pi times, integral of e to the u is e to the u, evaluated from 0 and minus pi, which is equal to pi times e to the 0 minus e to the infinity. Really the limit as e to the, or if you want that in another notation, okay, I could say it's equal to pi times, it's equal to the limit as n goes to infinity of pi times e to the 0 minus e to the n. Okay? That's another way to write it. So now what do we have? Well, that's equal to pi, e to the 0 is 1. The limit of that is just going to be 0. Okay, so now our answer to that whole thing was, so remember, we called that I, so we're going to say, well, we call that I squared. I squared is equal to pi times 1 minus 0, which is pi times 1, which is just pi. So I squared is equal to pi. Pretty cool. Which means that I equals plus or minus the square root of pi. But we can't have two answers, we can have one. So let's figure out. First off, this is what our bell curve looks like. Okay? So our bell curve is an area above the x-axis, so obviously it's going to be positive. And another way to look at it is we were taking the integral from the integral of e to the minus x squared dx from minus infinity to infinity, and e to any power is going to be positive. So if you sum up a bunch of positive things, you're going to get positive. So this integral is equal to the square root of pi. Alright, so I think that was a pretty simple and elegant proof. Yeah, alright, thanks for watching Math Heads 101. Subscribe and goodbye.